Okay, it's time to start the next video. What is the next video about? Well, someone asked some homework questions. 2 in 4-3, 2 questions, and 1 question. Someone else asked 1 question in 4-2. So let's show you how those childish things are done. They're very infantile. Okay? Let's start with the one in 4-2. So this is number 5. Let's do A in 4.2. Okay? It says, estimate the area, you could say it this way, under f of x from 0 to 10. Okay? Using 5 rectangles. And the right-hand endpoints. Okay? Then it gives you a picture. Let's widen this up so you can see it a little bit. There you go. Okay? Getting an unwanted shadow though. Okay. So it gives you a picture of the function. Okay? So here we go. Realize that A is 0. Okay? B is 10. Okay? N is the number of rectangles you have, or subintervals, that's 5. Okay? The change in x, the width of each rectangle, is b minus a over n. That'll be 10 minus 0 over 5. That'll be 10 over 5 or 2. Boogaloo. Okay? You're using the right-hand endpoints. So you have to start with the right. So the division looks like this. Okay? Just to show you a pictorial of it. I'm not drawing the function, that's drawn in the book. Okay? Here's 0, here's 10. Okay? Start at 0 and keep moving by the change in x. So the first one is 2, add another 2, that's 4, add another 2, that's 6, add another 2, and that's 6, that's 8, add another 2, that's 10. So those are the endpoints you're using, and you're using the right-hand endpoint. So it starts here, goes here, and goes here. Okay? Okay, and then you're ready to do it. Okay, use the picture in the book. Use graph of f of x in book. Okay? And so here we go. So the area, which is also equal to the definite integral from 0 to 10 of our function. Remember, we decided to call that symbol, and it's a limit of a sum. Anyway, it's roughly equal to, we are estimating, right? Right? It's an estimate. So it's roughly equal to, so it starts here. So it'd be f of 2 times the change in x, which is 2. Remember, the change in x is 2. I'll remind you. It's right there. That's the width of the rectangle. Plus f of 4 times the change in x, 2. Plus f of 6 times the change in x, 2. Plus f of 8 times the change in x, 2. Plus f of 10 times the change in x, which is 2. Now I'm going to do these. What is f of 2? Well, you have to use the picture in the book. And if you look in the book, f of 2 is -1. Use the graph. What is f of 4? Like I said, you have to use the graph of the picture that's drawn in the book. And if you look, f of 4 is 0. What is f of 6? You have to look. It draws the graph, and if you move over 6 and look, it goes down to -2. f of 6 is -2. What is f of 8? Again, you have to use the picture in the book. If you go over 8, the graph goes up 2. So f of 8 is 2. Finally, what is f of 10? Look at the graph, baby. Look at the graph, baby, in the book. If you look at f of 10, it goes all the way up to 4. So you end up there, and then just add it up. This is -2, that's 0, that's -4, that's 4, and that's 8. And that's all 6. And now my favorite part. That's the answer you see in the back of the book. Okay, so that was number 5A in 4-2. Do the rest yourself, okay? Do the rest of the assignment in 4-2. Okay? It's just that childish. You're just adding up numbers. Okay, now let's go to the questions that we're asking 4-3 and bust them out real quick. And then that's it. It's easy. Okay? The first one that was asked in 4-3 was number 17. Okay? So before we do this, I'm going to remind you about the fundamental theorem of calculus, FTC. Part 1, it said this, that if you look at this function, and take the derivative of it as it is a function of x, it claims that the derivative is just f of x. You just put the x in for t. It's quite easy to differentiate this function. Okay? Now, if you notice part 2 of the fundamental theorem of calculus, it says this: the definite integral from a to b of a function is equal to capital F of b minus capital F of a. Where what is capital F? I'll tell you yet again. Where capital F differentiates to be little f. Okay? Now notice this about thing 2 right here. Okay? If you look at the definite integral from a to b of f of x, and if f is always above the x-axis, then this is the area under this function f. According to FTC, that's equal to capital F of b minus capital F of a. Okay? Out of that, I'm going to factor a minus out. And so that will be capital F of a minus capital F of b. In other words, they got reversed when you factor a minus out. Because we can all do arithmetic, right? But then look at what FTC says this is. Now let's use FTC again, baby. Let's use it twice. This would be, since the a's first and the b's second, this would be the definite integral from b to a of little f of x dx. And so voila, you get that you can switch the order of those numbers a and b if you're willing to put a minus sign. a negative sign. So you can switch the order of these numbers here. See? They've been switched. Yeah. A to B, B to A. As long as you put a minus sign here. Okay? So remember that. Let's say it again, because that was like too hard. Let's say it slow. So the definite integral from A to B of f of x dx is exactly minus the definite integral from B to A of f of x dx, is what we've just learned. Capiche? With that, you can do number 17 and 4-3. Okay, number 17 and 4-3. You ready? It says, if y is equal to the definite integral from root x to pi over 4 of theta tangent theta d theta, find its derivative. Find dy dx. Remember, that's the name for its derivative. Okay? Well, the first thing is we realize from what I just said that y is equal to minus, and now I'm going to switch the order of these things here. So I'm going to put the square root of x on top, and now the pi over 4 on the bottom. Okay? Now that the variables terms is on top, we can use the fundamental theorem because it needs to be there. As you can see, let's remind you, it's on top. See there? Not on the bottom. So we have to make the switch. We can with this property. Let's put it in lights, because they said they'll see it if it's in lights. There's your lights. Okay? Got to put a minus sign. We've shown you why in like 3 steps here. 1, 2, 3. They're equal. Okay? So I did that. So I switched the order, but I put the minus. So now I can take the derivative. It's in the proper order to use the theorem now. So dy dx by f, the fundamental theorem of calculus, FTC. The derivative ignores a minus sign, so that goes there, and now goes to the function. That's a chain rule because there's not an x here. So it's a composition of there being an x here and the square root of x. So it's the derivative of the function doing the eating. That's the one with an x here. By the fundamental theorem of calculus, part 2, that's putting the x's in for thetas. But don't write that. Into that function, feed who he was eating. Okay, square root of x, tangent root x. Don't stop there. Then that's times the derivative of who he was eating. That's root x. That's 1/2 x to the minus 1/2. So that's one way to write the answer. But you won't see that in the back of the book, Johnny, because there's another way to write it. I'm going to rewrite this term right here. Okay? That's minus root x tangent root x times 1/2. And remember, that's 1 over x to the 1/2. You could write the answer like that if you want, just by changing this one. But you won't see that in the back of the book, Johnny, because I'm going to rewrite now this one. That's minus the square root of x tangent square root of x times, instead of x to the 1/2, I'm going to write root x, 1 over root x. So you could write the answer like that if you wanted to, but you won't see that in the back of the book. Why? Because you can write it another way if you wanted to, because these cancel. By. Put the half in front and you get minus 1/2 tangent root x. And congratulations, that is what you see in the back of the book. Capiche? Now the last question that was asked in 4.3. Shame on you for not seeing that yourself. By the way, is number 19. Number 19 in 4.3. This like plagued some people. They were mystified and confused. When it's simple, it's childish. All of what I've given you, all of this whole class, is based on childish thoughts that are 300 years old. But let's do it anyway, so we can be children too. Okay, it says compute this. The definite integral from 1 to 3 of x squared plus 2x minus 4. Can you say 4? dx. Okay, so we use FTC, part 2, fundamental theorem. I just have to find something that differentiates to be this. Shove a 3 in, shove a 1 in, and subtract. Okay? Okay, remember the integral comes into each piece, so when it comes here, that's a reverse power rule. Add 1 to 2, you get 3, divide by 3. Plus, it ignores the 2 and comes here. That's a reverse power rule, where the power is 1. Add 1 to 1, you get 2, divide by 2, it kills this 2, you get x squared. Minus, what differentiates to be 4? 4x. And now we have to evaluate that from 1 to 3. Stick a 1 in, 3 in. Remember, who goes in first, baby? Stick a 3 in. There's a 3 going in. Minus, better put some parentheses, or you'll get the wrong answer each time. Stick a 1 in and subtract. You get that? Compute. Okay. 3 cubed is 27. Divided by 3 is 9. 3 squared is 9. So I just did this one. And 4 times 3 is 12. So the first set of numbers come out to be that. Minus. Here you get 1 cubed is 1. Times 3 is times a third is a third. 1 squared is 1. So I just did that. I just did that. And 4 times 1 is 4. So I just do that. Okay? Add it up, baby. This all adds up to 6. Yeah? 18 minus 12. 6. Minus. And in here, I'm going to find common denominators. So this is 1/3. I can write the 1 as 3 over 3. Because that is 1. And I can write the 4 as 12 over 3. Because that is 4, Johnny. Okay? So I get 6 minus, add it all up, minus 8 over 3. Be careful. This all adds up to minus 8 over 3. The double minus makes a plus, baby. 6 plus 8 over 3. Write this in thirds. It's 18 thirds. And 8 thirds. And finally, you get 26 thirds. And now my favorite part. That's what you see in the back of the book. Okay? Do the rest of the assignment. Let's go. Do the rest of the assignment. Shame on you for not being able to do these problems. Okay? With that being said, I'll see you in the next video.